And I see faces that were here in the morning, so you're my heroes. That you're still, so excited also driving. So that's great to see. And hopefully, it's been so far a great tutorial where lots of information. I think one should, if you're interested in particular areas, you should watch again to really grasp all the different concepts and whatnot. All right. This works. All right, so I think we're going to get started. So the next thing I'm going to be covering is data and evaluation. So hopefully we'll be here for another 30 minutes or so, and then you will get the next step is simulation, where we have some really, really exciting stuff to talk about. And then after simulation, we will talk a little bit about safety, and then that will be it for today. All right, so we are almost there. All right, so let's talk about data, right? So let's talk about typically, what is the development workflow in the industry, right? So the way that this typically works is that you send your subset of your fleet to data collect. Typically, you are certain things that you're excited about, collecting, whether it's construction, emergency vehicles, just general driving, particular new areas that you're interested in deploying, or maybe simply you're just testing your vehicle and you're interested later on into utilizing some of that data. Okay, so you will do something where there is going to be a pretty large collection of this data. And one of the things that I don't know whether the folks have talked to you about, but actually, typically a self-driving vehicle collects around 1 terabyte or more of data an hour. Imagine if you have a fleet and whatnot. So when we talk data, we really talk big data, right? All right, but let's say that you have your fleet is collecting data, going around and whatnot, and logging, which is also very important, right? All this information. Then, as I mentioned when I was talking at the beginning of the tutorial, right? Typically, when you're in academia, you're given a data set, and that's the only thing that you know about. Here, because you have this massive amount of data, you have the ability to decide what is the part of the data that is interesting for what you're trying to do. And oftentimes in the industry, there is something, and sorry, I'm going to go on a tangent, but I'm just going to tell you stuff. Oftentimes in the industry, what you will see is that every team cares about something else or something different, and then you end up with many data sets. At Waabi, we don't believe in that. We believe on trying to get comprehensive data that actually everybody can use, so that you end up with things that are always compatible. You have labels for everything you're interested in, etc. I think it's a much more organized, structured way to move forward. All right. So, but since you have this very large collection, right? The thing that you need to do is decide, well, what I'm interested in within this large collection of data, and that's actually not a trivial thing when you have many hours, right? Many potentially millions of miles of collected data. So we are going to talk about in a bit about how you can curate based on different criteria that you might be interested in. And then based on this collection, typically you create your data set for what you're intending to test, if it's a data set for testing, or you're intending to train if you're actually, or maybe training and testing splits and validation splits, right? And then you're going to train your model, right? That's typically what happens. And then you're going to evaluate, and then you're going to discover, well, maybe my model doesn't do so well in this thing. And then you're going to go back and then try to maybe collect more data or curate more information, etc. So this is data sets is something that is not static. It's something that actually is in continuous development. And this can be at times a bit daunting in the sense that you need to make sure that you also have a very good way to measure progress. And if you change your data all the time, you can't do that, right? So you need to have a clever way to still measure progress while improving or increasing your data sets. All right, so I'm going to be talking a little bit about data sets. Then I'm going to go into data curation and then show you some ways that you can do this. And then at the end, I'm just going to very briefly talk about the evaluation. And it will be a segue to Steve and Kelvin, where they will talk to you about simulation. All right, so this is my one slide about data set. And I start with, something that is very dear to me, which is Kitty, right? Something that actually was my first paper in self-driving, and it was work with my former student, Andreas Geiger and Philip Lenz, and it's what got me so excited about self-driving. Once, we spent actually almost 3 years into creating Kitty. So it was a very, very thorough work, and really, it was just the beginning in terms of, oh my God, this problem is so exciting, so complex. There are so many things that one can do to bring, AI, machine learning, next generation thinking into how to solve this. So probably there is a few that have appeared at CVPR already and whatnot, right, over the past couple of weeks. But in general, you see that there is more and more a very large collection of data sets, some of them for a subset of different tasks. That it's great to see that this really empowers the academic community to do a lot of different work, right? And that's kind of the slight tribute to this is great work by many people, many different companies. All right, so let's talk about when you're creating your data sets, right? Regardless of what it has been provided to you based on those data sets, what are the factors or the variables that you need to think about? Well, the first thing that you need to be intentional about is what are the sensory modes that potentially are going to be interesting. And when you create your data sets, you need to be forward-looking. And what I mean by this is that if, let's say that your perception system only tackles or only employs a subset of the sensors, you shouldn't just remove everything else, because maybe one day you will have something that's more sophisticated that requires more data, right? So that's something to take into account, and maybe you want to log everything as you create the data, right? But Andre talked to you about all these different sensor modalities, and potentially these data sets are actually contain all these different information sources. Also, for the way that the field has evolved over the past couple of years, is that if you can have high definition maps and you can build them at scale, then this is a great source. So you want to make available those maps as well in these data sets, right? And then the question also arises in terms of, well, it's not just about the maps themselves, but how do I represent them? So that I can actually enable people to do all these different techniques that potentially require very different representations. What do I mean by this? Right, you learned today about rasters. So that's, use rasters, almost everything is going to work for you. But for example, if you use link graphs, more structured vectorized representations, then hopefully the data set that people are either you are creating or that people are going to give you contains representations of that form, so that you can indeed do that research. Okay, so that's something to take into account. Semantics, right? You want to have, as I said, not just many different data sets, but data sets that can enable many tasks, right? Also dynamic actors construction, all sort of stuff. The other thing that you also need to decide as well is what is going to be your source of annotation. And we've seen right now something pretty interesting, which is, when I built Kitty with Andreas and Philip, it was all about high quality annotations, and it was pretty large scale for the time in 2012, right? Now, a lot of the data sets, or the newest data sets, have evolved to maybe one quantity over quality. And it's not, I would say, it's not 100% clear to me that that's actually the way that we should be going. Right, but that's something that is related also to the types of annotations. So what we see in some of these data sets, like Lyft, some of the WIMO data sets, etc., is that the bounding boxes and whatever are not real labels. They are actually outputs of an auto-labeling process. And you need to understand that this is going to come with some caveats. For example, it's going to be noisy. Maybe your kinematics are not great. Maybe you have collisions on your data set, and your model might be actually learning things that are actually not something that you want it to learn, right? So careful as well in terms of understanding the quality of your data and taking this into account when you're building your models. And I'm not going to argue whether that's not good versus not. It's more about you need to know what you are going to use in order to understand the potential failure modes of your system. Right, so it's not just about quantity, there is also about quality. And I'm actually a big fan of hybrid things, where maybe you have some annotations that are high quality and some others that are not. And the last bit, right, is about, okay, what is the data in the first place, right? How do you define interesting? you want to be able to generalize across different areas. So geodiversity is very important. And coverage in terms of scenarios, situations, things is also very, very important, right? And oftentimes when datasets are released, nobody's talking about any of these things. Sometimes you will see over and over driving on the same area. Well, that's not going to test geographic diversity and generalization, right? So you have to be very intentional in terms of why you are deciding to release or to do a particular data set. Okay. Hopefully this is clear, right? And there is so many variables, and a lot of it is into selecting the right thing for you, what you want to do. All right, so let's talk a little bit, since sensors, Andre talked about it, high definition maps, also Andre talked about it. So let me talk a little bit more about annotations and curation. All right, so annotation types, right? And there is many things that one can do, right? You can, typically we are excited about semantics these days, maybe with some of these foundational models, less semantics, but still they're very, very useful, right? You can have, things on labels on image space, three-dimensional space, bounding boxes, occupancy stuff. We like also to have more semantic, kind of like behavioral things of what the different actors are doing, right? And you can go into different levels of, I would say, details in terms of, what do you label where, right? The thing that you need to be very intentional as well is that these annotations, some of them are extremely expensive, right? And at the end of the day, you have a budget, fixed budget, right? You have a large collection of data, and you have a fixed budget, how much you want to spend for your data set. And then you need to choose, the recipe in all these different dimensions, so that, you can do what you want to do. All right, so I mentioned that there is a search these days of, in terms of annotations, to go from the, super high quality annotations to something that is more automatically generated, right? And this is interesting because, there was a boom maybe a decade ago where mechanical Turk was a thing, like, oh, cheap annotations, but then for self-driving, it's like, no, we don't want that thing. We want actually really precise stuff. And now we are seeing moving towards, oh, by the way, maybe I can build perception systems that are actually really clever and can give you good labels, right? And that's a very, very, I would say, powerful approach. And you can use different types of perception systems. One of the things that you can do is use the onboard system. And that's actually, very cheap in the sense that oftentimes this data, when they capture, you can actually run it on the vehicle. So you don't even need to process anything. It's already, the information is there, right? And don't forget that you're running this at the scale in this, terabytes and terabytes of data. So actually your bill is going to be high, very, very high, right? So this is actually a thing. The other thing that you can do is build perception systems that are more informed, that actually understand the fact that you don't need to run it, in a sequential manner. You can run it when you offload your data, right? When you actually have the full, data set or set of snippets or logs that you're interested in. And then you can build, more sophisticated perception systems, typically, and they will look at a relatively small context around the vehicle, but you can center, in the area of interest. And that's the kind of, techniques that you see a lot of auto-labeling approaches, right? And if you look at the evolution of these auto-labeling approaches, they typically, or the most, I would say, the best performing techniques work in a way that is very simple, where first what you do is you run, a standard perception system, typically on-board type of perception system, where you detect and then you track. And that serves as initialization for a more sophisticated temporal kind of reasoning that is a refinement stage that can maybe attend to more things in space and time, right? And then you can, because now you have identified where objects are, you don't need to run it everywhere, so you can actually do things that are computationally more sophisticated than what you run otherwise, right? And that's, there is some papers here by, we did in the past, Waymo has done, there is one, the CVPR, and there is some really exciting things that hopefully I can talk about you soon, but not today. All right, so that's, the way that you can extend potentially your labeling to now you can auto-label everything, right? But you can't use everything for training either, right? Because then your AWS or whatever your cloud provider is going to grow as well. So you need to curate that data, right? So let's look at what are the ways that you can do this. Right, so you have millions of miles or whatever it is that you have, right? At Waabi, we don't drive so much. We actually like to do a lot of things on simulation, but you still have quite a bit of data, right? And then again, you need to create these data sets that cover the long tail. And I'm obsessed with efficiency. I'm obsessed with building things that actually don't cost a lot of money. So now think about using your brain in order to decide what's important. All right, so what can you do with this? So we're going to look at 3 different ways of doing dataset creation. The first one is going to look at defining interesting things. Okay, so we're going to come up with some way of defining this concept. Then we are also going to look at the concept of diversity and coverage as a way that's also important for selecting your dataset. And then we're going to look at the alternative, which is, well, I'm doing this to improve my model, so maybe my model can tell me where to look at, right? That's another active learning-like way of deciding what to label. Okay, does this make sense, right? So there is like these 3 different ways, and let's look at a couple of examples of both of the 3. All right, so let's define interesting. So how can we do this? Well, maybe one thing that we can do is define what engineers working on this field, or safety folks or whatever, believe are things that are important or interesting, right? That's one way. And then we can build tagging systems that automatically can tag every single row log with those interesting things, right? That's an approach that works fairly well. When you have safety engineers also on board, they can tag by hand. That's another way that you can create data, right? But you can build, tagging systems that you can also do retrieval with those. Right, and you can decide, for example, well, I care about heartbreaks, maybe of the SDV or maybe the actors around me. I care maybe about things such as, going into particular intersections or particular types of traffic light situations, or scenarios that have a lot of factors, or scenarios with very diverse type of factors, etc. Right, and then you build this tagging system that can actually tell you when this happens. All right, so. But if you want to do this and run over your, hundreds or tens of millions of miles, you need to do this in an automatic manner, right? You can't just tag, this by hand. So you're going to learn kind of, there's like 2 types of ways to do this. Something that is very common in industry is to do this in a way that is a little bit of how typically perception prediction motion planning works, which is to say that we're going to use our perception systems, our trackers, etc., to define, given row logs, right, with your sensors, to define what's happening in that scene, right, automatically, right? And then from that, we will have some kind of logic, typically rules-based or not very sophisticated, that takes that information and then tell us whether certain things happen. And you will see many instances of this in many of the major companies out there. Okay. So if you can do this very well, and then your rules are actually very tuned, then maybe you can do this well, right? There's a lot of maybes on that statement. The alternative, right, is to do something different, which is, well, why do I need to go through some intermediate representation? Maybe I can build a tagger that directly works from raw data. And this in the past was thought to be, or maybe this is a much worse approach, but these days with LLMs, maybe, right, this is actually something that you can do really, really well, right? Does that make sense? Right, so you can maybe use your favorite LLM here. All right, so for rules-based systems, right, let's look at what we have. So we have more than just the output of a perception system, right? We can use the high-definition map, right, because maybe some of those concepts of interest might be map topologies that are, different. And also we have everything recorded for the self-driving vehicle, right? Typically, we log everything on the logs, right? So you can use that information to define also interesting things. And let me just give you a few examples, right? So you can look at measures of map complexity, right? For example, how many motion paths you have, how many lanes are they? Is there a lot of diversity in terms of how they are, in this particular area. Do you have crosswalks versus not? Do you have lane crossings? Do you have a railroad or something that is, on this map and might make it actually really complicated for the system to handle? Do you have traffic lights? Do you have, San Francisco, right? Map height, meaning changes of slope, etc. Lombard Street, for those of you that have been in San Francisco, might be very complex, right, as well. Right? So you can kind of define all these things that are, make sense. And here you see some examples of low complexity, high complexity, right? Or low interestingness, higher interestingness. With respect to the actors, you can do similar things, right? You can think of, do you have a lot of dynamic actors in the scene? Is there a lot of different classes, so that is a very rich scene also in terms of diversity? Is the diversity also spatial? Maybe it's something that you're interested in to understand whether your system can actually handle all the different things. What about velocities? Is everybody doing the same thing and it's boring, or do we see like really different behaviors within the same scenario? And also, what are the paths that the different actors are actually going on? Right, and these are just examples, right? You can go and say, what about the self-driving vehicle, right? You can think of what is the path of the self-driving vehicle, right? Is something that did something weird, so maybe I want to actually use that as an example for training later on. Is the self-driving vehicle having velocity diversity, meaning it has acceleration, right? Or deceleration, right? Hard brakes. What about the route, right? Is it doing a lot of changing lanes, etc.? Is it interacting with traffic lights or with other actors in very interesting ways, right? Maybe safety critical situations, etc. Right? So you can define all these different kind of tags. Right? Does that make sense? Right? And then you can use this standard system. And that's, I will say, and I see some of the industry players here, I'm sure that you guys have a version of that, maybe at Zoox, a version of that, in your software stack. The alternative, as I said, is that you can learn. So a few years ago, we built something that is funny because it has a structure that is very amenable to transformers, for example, but this was before transformers were popular. So you can do this thing with transformers or your favorite model, right? Where basically you can learn representations that are space-time, that are queryable. And then you can learn representations for the attributes that you're interested in querying about. And you kind of dot product them to say, is this happening here? Right, so it's very, very similar to how transformers work today, right? And you can do the same thing to basically say, well, if I look at my space-time volume, these are all the different areas where some of these things are happening. And you can utilize this to automatically decide in terms of where you want to potentially focus your labeling efforts, okay? And now we don't need to run all these different systems and then some heuristics on top. You can directly do it with your favorite, as I said, model. All right. And at the time, it's very interesting because you can also do question answering and things like this, right? Again, something that you can do with modern versions of this today, where you can ask questions about how many vehicles are in the scene so you can count. Right, you can ask about other pedestrians. Can you identify whether they're crossing a crosswalk? Because maybe that's something that my vehicle cannot handle very well. So I'm interested in labeling more of that stuff. Or what is the maximum speed? Or are you going over the limit or whatever? Cool. So cool. The other thing that you can do is you can use this as a retrieval system, right? Or you can also optimize. That's when it gets actually pretty interesting. This is some of the things that we have done in the past where you can optimize over so that you can select the data set given a particular budget that maximizes your utility, right? So you can build such an optimization and select based on this criteria. All right, so diversity, right? Coverage is something that it's a different way to generate this, right? So hopefully the interesting was very clear, right? It's very natural, right? Now let's talk about, well, it's not just about interesting things. You want to make sure that you cover everything that potentially you're going to see. Even if maybe it's less interesting, but at least I should have one example or something that is reflective of that type of scenario, right? So the idea is that, it's going to be a high-dimensional space. Obviously, this is in 2D here. Right, and you have labeled some of the scenarios. This is in yellow, right? And then what we're going to do is look at, selecting points that actually will be diverse with respect to anything else that we have labeled so far, right? And this is how you, little by little, build the coverage of all the things that you might want. All right, so this is interesting because oftentimes, people obsessed with active learning and trying to improve models in order to decide what to label. But it turns out that in self-driving, this is not necessarily the most effective way. And the reason I'm saying this is that you typically evolve your models. Maybe today you have this model, but maybe tomorrow, it turns out that you use this other fancy backbone or this other fancy way of doing things. And then you have overfitted your labels to that other model. But it's not necessarily the best set in terms of, for that money, for your next model, right? So this concept of interesting diversity, etc., is something that enables you to go beyond your one model today to think about any set of models that you might have. And also what is important is when you do this is that it's not just about perception, right, or whatever. It's about, I want a data set that I can do perception, prediction, motion planning, control, and evaluate all these different things. So I have so many criteria already. So maybe it's many models already that I'm interested in. And instead of building these separate data sets that, doesn't enable you to train end-to-end, instead, let's focus on maybe a general data set where I can do these many things. And what these numbers are showing is that, it turns out that you can generalize better across models if you actually use these more general concepts. And so that was interesting and something that was very different from what typically you see on papers. All right, so however, I still need to talk about active learning. I'm not saying that this is not interesting. This is just one way of many that you can actually select what to label, right? And the idea is very simple, is that you can base on your model what it's spitting out. You can decide what potentially is going to be very useful for you to know the real answer so that you will do better at the task that you're interested in. And there is different criteria, right, that you can utilize. These three criteria here are typically the most used, in I would say in the community where, information gain, right? Give me the label that's going to give me more information, right? If I know what a label is, obviously I don't know what it is, but I have some notion about potentially what it could be based on my predictions. Right, so you select the set of labels that, again, will give you more information, right? That's a very, very natural mathematical way to define this criteria. You can look at entropy as well, right? If your model is very uncertain, you probably don't do that very well. So you probably want to know what the answer is there. So that's another criteria. If you are interested in things like, for example, you have a more of a max margin classifier, right? You can look at the margin as a way to define what to label next, right? So that you have, a better margin. There is other stuff that have been done in the literature where, you kind of try to bring diversity within active learning as well by kind of covering your space or other things. For example, this is a relatively strange, I would say, way of doing this, which is to look at, given your prediction, what maximizes the gradient. Go figure. All right, so that's our ways that you can do based on models. And you can also, in the industry, there is other criteria that you can use. Oftentimes, interventions are the number one thing that you label. It's like, my system failed. Well, I want to replicate that on simulation or somewhere else. So I'm going to actually get labels and see where my system actually failed. Right? So that's typically a loop that you will see. And Tesla does this, at the scale, for example. You can look at things like temporal inconsistency of your predictions, meaning that if in 2 consecutive frames I'm predicting very different things, well, probably my model is not doing the right thing, right? So that's another different concept that now is about how consistent you are, your uncertainty, if you wish, over different consecutive time steps. Some of the things that you can do that is very interesting is, we've been talking about labeling a data set. Something that we like we did in the past is to break that down from, well, you don't need to label, because that snippet is interesting. You don't need to label everything. That's very expensive, particularly as you want to have data sets that have all these different sources of annotation, right? You're going to select very few if you need to label with semantic labels of this type, that type, and other what, right? So we look at building active learning algorithms where not only you can select kind of the snippet that you're interested in labeling, but where in a space and time, and you can do it in a very, very fun way, right? So for example, given the scenario here, you can decide that this area, well, parked cars is very interesting. I can do this already. Maybe, wow. Maybe some of these things are more interesting. Maybe these are things that might be interacting with the self-driving vehicle. Maybe I prefer to label this area versus anything else, right? So you can do this in a very fine manner where you can get annotations that are very interesting with a few dollars. Now, what is the difficulty of this? Assuming that you find an annotation provider or yourself that can do this, which is fine, where you can specify a region of interest, that's fine. The problem is that now you have to learn in a weakly supervised manner because you don't have annotations everywhere. So the complexity is put to your thinking and your algorithms versus the labeling and clicking. Okay, so you still need to do things in order to understand how to incorporate this source of information in your training pipelines. Cool. All right, but you can still do that, and actually it turns out that you can label things much cheaply. What we're showing here is just this type of, active learning approach by selecting, really fine regions, right? Where you can actually, for the same cost, you can have much better performance in terms of different downstream tasks, perception, prediction, and even motion planning. And this is the kind of thing that the system actually looks at. It can look at things like, well, the model is uncertain, or there's something really interesting in this, maybe it's nudging, or complex interactions, fast driving, U-turns, all these different things, but you don't need to label these hundreds of other vehicles, just focus on the thing that matters, right? So as I said, a very, very, obviously powerful idea, but comes with the caveat that weakly supervised training is non-trivial, and it's really non-trivial. All right, cool. So that's kind of for dataset curation, the ways that you can do this. And let's talk a little bit about evaluation. And with this, we have a couple more slides, and then we will go to simulation. Okay. So in terms of evaluation, right, you have typically you need to have an evaluation set that is obviously different than the training set. And here I'm preaching to the choir, right? You guys know this because you do machine learning, right? Now, it's interesting that in industry, this is not well understood everywhere. And this comes from the fact that a lot of people come from a more hand engineering approach, where this concept of training, testing, diversity, different, whatever, is actually not part of the way that they are thinking. And that was actually, or that they optimized to, yes, one canonical route of this, you overfit all your data and whatnot. So that was surprising to me. Obviously, this is something very, very important, that you need to really understand your generalization capabilities. And you should understand that generalization from day one. Okay? So when you build your data set, make sure that indeed you have a good split that is really very, very different. All right. So that's important, as I said, for all these different metrics. So what's happening here? Cool. And in terms of supervised learning, right? This is very, very simple, right? You have your data set, you train your model, and you evaluate. Right. And a lot of, let's say, perception teams in the industry, et cetera, work this way, or prediction teams as well. I have my data set, it's for my task, and this is the way that I'm going to do model improvements. And then I will hope that when I do this, it's going to improve my system level metrics. Oftentimes, it's not the case. There's a big disconnect if you do this. So it has, big, I would say, caveat in terms of, maybe you improve that model, but you're not going to improve your system. So who cares about that model if you don't drive it, right? All right. So you can do things like, we're starting to see a little bit more in academia, right, of this, which is, well, we should go downstream, right? Even if you're developing a perception algorithm, you should look at how is this affecting system, for example, at the planner level, etc. But so this is better because now you are closer and closer to your task, right? But still, this is open loop. This is not great in the sense that open loop metrics don't really tell you whether the full system is performing well. And it's mind-blowing how certain systems that have fantastic open loop metrics are terrible once you implement them and you put them on the vehicle and then you let that vehicle drive. Right. So when the system is very bad, open loop gives you a signal. When the system is pretty good, there is very little that you typically learn from the system. So that's not great. So what do people do in the industry? Well, let's put it on the vehicle and let's drive. Right, that's a good way. And then I will count interventions, I will count failures, I will count heartbreaks, things that my vehicle might do. Right, and I will have metrics based on these things. Now, this is great in the sense that it's real work, but it's so expensive and it gives you so little signal and it's not repeatable. And it depends on what you saw that day with that particular vehicle, right? So it's actually, and it could be unsafe if your system cannot handle many situations, right? So this is also not great, although we are moving more and more towards the performance of the full system. Right, so the best way to really evaluate this is if you have a simulator where you can test the entire system. Right, so that simulator needs to be able to simulate the sensors, the behaviors, everything has to be reactive, has to look like the real world. And that's the kind of thing that I show you at the beginning, right, in terms of what we want and what we are building, right? This is a much, much better, much more scalable way, much safer way to actually build evaluation systems, okay? And now Siva and Kelvin are going to tell you all about simulation, what are the core components of simulation, and how you can build a system towards something that looks like this. All right. And with this, I'm just going to conclude that hopefully you get some at least some insights in terms of how you can build data sets, what are the things that you can take into account, all these different ways, and how in general there is no one that actually is much better than the others, that you need to build complex systems that take into account many, many different ways so that you have the best thing for the least amount of money in the safest possible way. All right, thank you. All right, questions? Maybe one or two. I'm destroyed.
So the last part, I guess you assume that a very performing simulator. But how can you measure the performance of the simulator?
Yeah. So one of the things that when you are very based on simulation that you need to do is you need to validate and verify the simulator. And the exciting thing about the type of simulator that we are building, because it's based on digital twins, you can actually measure domain gap of the simulator in many different ways on every piece of the simulator, as well as the effects in autonomy. So with Waabi World, you can actually indeed look at how realistic your simulation is, and you can measure mathematically that realism. And that's something very, very exciting for what we are building. And this is why we're using this as part of our safety case. Now, I haven't talked about simulation, that these guys are going to talk about it. So wait and see. And then hopefully, that will answer your question. One more? Okay.
So much. I'm curious how you think about balancing, how you weigh interestedness and coverage and model equipment for your labeling budget.
Oh, fantastic question. I don't think anybody has the magic algorithm to do that. I think is, something that I would say is an open question. And I would say that you can do meta learning on top of all these things, for example, as a way to learn that. But I haven't seen anything like this so far. But it's a great open question. So here I gave you all the axes of variation. I didn't tell you how to actually combine them. Every company does this in a different way. All right, thank you.